So I was a teaching assistant in graduate school, you know, doing the labs for the professors and grading the papers and that kind of a thing. And then when I did my research, the money kicked in from the funding agency, which was the National Science Foundation, which was able to pay for my research. So there was not a lot of financial difficulties at that time. Now, that may be different for students now.
But what about family?
Family was there to support me. I mean, certainly my immediate family was there, and they were supporting me in every single way. Extended family and you know, more distant family or more immediate family were supportive, because it takes a certain amount of solitude and concentration to do these kinds of things, to study and all of that. But yeah, it was, you know, I had the patience from immediate and extended family to give me the space for which I could use the time to, you know, study the subject. But it's always good for any student to try to find balance. Don't get to the point where, you know, you neglect your family or you neglect your friends. Try to get some quiet time or get some social time so that you don't become a recluse. And that reduces the stress that you all go through. So I would say that get you know, a circle of family and friends who are supportive of you, but not so supportive that they allow you to drift and to become a hermit, which is not good for anybody. Yeah.
Yeah. And how was life in the four-year university?
Well, life at the four-year university was fairly stressful in some ways. I went to UC Berkeley, and UC Berkeley, at the upper division level, I did my undergraduate first, you know, 2 years at San Francisco State. And after 2 years there, I went to UC Berkeley. UC Berkeley was somewhat elite in, you know, the reputation, the teaching styles of the professors, but it was actually very family-oriented in the sense that you became family with your students. So you would suffer together, you would work in groups together, you would go to the coffee shops in the neighborhood together, that kind of thing. You would have a second family. And even though the work was very, very hard at UC Berkeley, you found collective support with other students that reduced your isolation and reduced your fear of failing, because we all went down together, if we did. Now, that's an exaggeration, but I will say they tend to grade on a curve at UC Berkeley. So even though the exams are very, very, very difficult, you know, the curve puts you in a rank similar to other students of comparable ability and background. So I got used to getting kind of not great scores on exams, because everybody didn't get a not great score on the exam. You get used to getting exams that are too long and hard for you to finish in an hour, but you don't feel bad because everybody was in the same boat. And so, you know, you get used to getting, you know, 60% on the exam and getting a B plus or an A, because everybody else turned out to have the same average. So the four-year university for the upper division is not that bad. If you get in, it's not that bad once you get there.
Right.
Yeah.
So we still need to keep working hard, right?
Yeah.
And teacher, you teach like really hard for most of the people subject, and most of the students think that physics is like impossible or like a monster. I would never get it or something like this. What kind of suggestions do you have for them, like to not see physics as impossible stuff?
Well, It depends on what you want to do. I mean, if you think about a difficult problem, it will be impossible to solve. There are many problems that are impossible to solve. Now, I'm not telling you not to think too much, but one thing you can do is focus on the material and don't go too far on a tangent, so you don't go to a place that you can't pull back from. Because physics, as I say, is a difficult subject. But the main thing is to practice as many problems as you can. And even Richard Feynman, who was very good at problem solving, recommended problem solving, where if you do many problems and increase the difficulty of them as practice, when you're taking these courses, you become, you could say, hardened, and your mind becomes strengthened, and you become developed mentally, like any subject, playing chess or other subjects or activities that require skill, require practice. So one thing is to leave a lot of time to try to do a few extra problems than just the homework.
But some people just say, like, physics not for me. I mean, they don't have motivation, right?
Even the engineering students?
Oh yeah, definitely.
Well, that is in part the role of the teacher to make it relevant, and sometimes it's difficult for me to always put the applications. I try to do that as much as possible. For example, today I tried to talk about how electromagnetic waves affect us in major ways with regard to television propagation of waves, or radio propagation of waves, or cell phone propagation of waves. So physics is everywhere. I mean, it's the laws that govern everything that you see. I see a reflection on that table because the light comes down from the light bulb up there, and when it hits the interface here, the photons are reflected because of the electrons that are in the surface material that don't absorb the light if they're free electrons, for a variety of things that have to do with conservation of momentum and energy, so they tend to reflect the light. And so reflection of light every day is a common experience that it's good to have knowledge of, or when you're driving down the street or a lonely road on a hot day, you notice that there are puddles that look like water is in front of you. That's not water, but it's actually light that has come from the sky. Because of the changing speed of the light in the hot air above the road, the light bends upward towards your eyes. So the light is descending from the blue, and as it gets to the hot air, it bends upward towards your eye. And you're not seeing water, but you're seeing an image of the sky. Now, that's a physics explanation that, you may not have to know, but it's interesting to know that it isn't real water up there. So, you don't necessarily have to drive any more carefully than you normally would, because it's not going to be wet. Or other examples of physics occur in the mechanics of sports, and the projectile motion that we see on the sports field, the football field, or the baseball field, to get an idea of what the velocities are that cause the ball to go out of the ballpark, can be explained with simple computations. So it is endless, the number of things that we can talk about with physics, just on an everyday basis. At the same time, if you're an engineer, there's an underlying physical process behind the computations and calculations that you do. So if you go into mechanical engineering and you're interested in the structure of the building, then you want to calculate